Okay, folks, let's get started. Good morning to all of you, and welcome to this presentation on networking for cloud services in Windows Server 2012 R2. My name is Anand Ramachandran, and I am a senior program manager in the Windows networking team. We work out of India. In today's session, I am going to be covering two things. I am going to be talking about DHCP, DNS, and IPAM in Windows Server 2012, and then I am going to move on to talking about the same components in R2. I'm going to talk about what the new things are that we have introduced in DHCP, DNS, IPAM and R2, and then I'm going to show you how some of these features can be used. The main takeaway for you from the session is going to be that 2012 IPAM or 2012 R2 IPAM is a very cost-effective, scalable and customizable solution which can be used for the unified management of both your physical and virtual network IP address spaces. It can also be used for the management of DHCP and DNS servers, and all this works both in enterprise and hosted environments. So let's get started, folks. To start with, I would like to know how many of you have tried out or tested or deployed the Windows Server 2012 IPAM solution. Good, we have a few folks, so I think you would be able to relate a lot with the content I have here. And how about DHCP and DNS, Windows Server 2012? We added a lot of good features there, which I'm sure would be useful to you. So I'll start off with a quick overview of what we have done in the DDI space. By DDI, I mean DHCP, DNS, and IPAM. Okay, so here I have very common IP address management tasks that administrators perform on a very regular basis, almost on a day-to-day basis. I'm sure you have a very good idea about what these tasks are. You might have a much clearer picture about these than even me. So I'll give you a few seconds to take a quick look and digest them a little. But they all basically fall under two or three main categories. One is the management and the monitoring of all the IP addresses that you are using in your network, and second is the management of DHCP servers, and third is the management of DNS servers. So we have a few tools in the market, namely spreadsheets, in-house tools, and third-party solutions, which organizations were typically using to perform all those tasks. You might have even deployed some of these solutions yourself. Now, all these solutions are good. They have a lot of advantages, but they also have many drawbacks, ranging from the fact that they are not very cost effective, they are not scalable, and going into things like they are not very customizable. It is very difficult to maintain them. It is very costly and time consuming to service them, etc. So what we did in Windows Server 2012 was Microsoft added an inbox solution for IPAM, which is cost effective, scalable, it is very easy to use, and it is the ideal tool for the management of your address and naming infrastructure in your networks. So I'm going to start off by giving you a quick overview of what we have done in IPAM in 2012. So there are 3 or 4 main areas of investment for IPAM in 2012. The first and the foremost is the address space management. So this is where you go and create address spaces, you organize them, you assign them, and once you have done all that, you are able to monitor all the different IP addresses through IPAM. We support both static and dynamic addresses. You can go and get addresses from DHCP, you can define them in IPAM console itself. We support both V4 and V6 addresses, and not only that, when you go and enter an address in IPAM, IPAM can automatically detect whether it is a public address or a private address. Then going on to network discovery, IPAM has the capability to go and automatically discover all the DHCP, DNS and domain controller servers that are there in your network, and you don't need to do anything on these devices in order for them to get discovered. You don't need to go and install an IPAM agent or anything. IPAM is an agentless solution, so it automatically discovers these servers as they are, and not only that, it can also go discover the configuration and populate the UI so that you can actually look at what is there on these servers. For example, you could go and take a look at all the DHCP scopes. You can take a look at the zones in the case of DNS. IPAM then provides multi-server management, so you have a centralized and a single console from where you can not only manage one DHCP servers but all your servers. So if you have say 3 or 4 DNS servers, you don't need to go and log into them separately. You have all those views right in front of you through a single IPAM console. Then going into auditing, IPAM allows you to monitor the kind of administrative tasks that have been performed on your DHCP DNS servers, and not only that, it gives you the capability to track your IP addresses. So you can do things like find out when an IP address was assigned, which machine it was assigned to, what time it was assigned, how long the machine used it, etc. So you can do all sorts of tracking activities with your IP address. There are a significant number of investments that also went into DHCP and DNS in 2012, which complement all our IPAM offerings. The first and foremost is DHCP failover, which I think a lot of you would benefit from, and which has been an ask for a very long time, which we finally went and added in 2012. Now, DHCP failover gives you both an active and an active standby configuration, and not only does it monitor the continuity or provide you DHCP server continuity or DHCP service continuity, it also gives you continuity of your IP addresses, which means that all the IP address leases that you have on your active server, they are all preserved when you switch over to a standby server. Then we added DHCP policies, which essentially allow you to define certain conditions or rules, enabling you to go and group different devices in your network. And then based on the groups, you can go and assign different network parameters to them. So you can segregate your printers and assign them specific IP addresses. You can segregate all your mobile phones and give them specific proxy settings, etc. Extensive partial support was added for both DHCP and DNS. We have near 100% parity with whatever you can do through the DHCP and DNS UI. And all the partial commandlets are based on WMI. And then going to DNSSEC, there were some important features that were added in that area also. DNSSEC for a long time did not have a UI through which you can go and configure it. Now we have a UI which integrates with the DNS MMC. DNSSEC got its share of partial commandlets too, which are again WMI v2 based. And not only that, DNS supports online signing of zones to protect it from cache poisoning. And we also support something called NSEC, which ensures that failed queries are returned in a secure manner. So that sums up the kind of investments that we made in IPAM, DHCP, and DNS. I'd like to show you a quick demo, and so that you know what we are doing in the address space management area. So there are many different parts of IPAM that we can get into, but today I want to show you a little bit about address space management. Okay, so here is my IPAM server, and this must be a familiar console to a lot of people who have deployed IPAM. Of course, this is IPAM on Windows 2012 R2. So some of the menu options that you find here, you might not have seen on your Windows 2012, but the screens that I'm going to show you will be familiar. So I'm currently looking at all the IP address blocks that I have defined on my IPAM server. So, I can just scroll down and look at all of them, and the color mark that you see here shows you the utilization of each of these address blocks. An address block is nothing but a block of IP addresses which contains many different subnets. Blocks also have subblocks. They also have subnets. I'm sorry. These are the IP address blocks, and what you saw earlier was the subnets in those blocks. In Windows 2012, you don't have subnets, but that is something which we have added in R2. And then we have IP address ranges, which shows all the ranges that are present in the blocks that we just saw. And the color mark on the extreme left shows you the utilization. And you can get a lot of other information about these ranges. For example, you can see what the start and the end IP addresses are, and then what the assignment type is, what is the percentage utilization of these addresses, how many are assigned and how many are utilized. And there are a lot of other columns that you can keep adding to this table. Now, this gives you a very flat view of all your IP address ranges, which might be confusing in some cases, because you might want to categorize them and view them in a more organized fashion. For example, you might want to say that, hey, there are so many ranges, they all belong to many different countries and regions. It would be so good if I could view all these ranges by country or by region. And for that, we have something called IP address range groups, which essentially is a essentially is a UI element that lets you go and organize your IP address ranges in the format that you would like to see them in. So let me show you how an IP address range group is created. So I go to IPv4 and I say add IP address range, and let's say I want to group them. Yeah, so that's IP address range group. So let's assume that we want to group them by the geographic region that they all belong to. So I'm going to call this geography, and then I'm going to say group items by region first. And once they have been grouped by region, if there are many IP address ranges which fall in one single region, then group them by region or country. And then I click OK. Now when I do that, it automatically creates this IP address range group that I just added called geography. And then if I expand that, you will see that there are many different regions, and each region has countries or other regions under it. So say, for example, I click on Australia and New Zealand. I only view the IP address ranges which are there in that area. So I'll just show you that quickly. So I'm selecting Australia and New Zealand, and I select IP address ranges. So that shows me all the IP addresses that are there in Australia and New Zealand. If I expand this, I see the countries, and if I click on Australia, I only see those ranges that are present in Australia and those that are present in New Zealand. The other thing to note with respect to IP addresses is that we support v4 and v6 IP addresses, and you can look at both public and private addresses, and like I told you, IPAM automatically identifies whether an address is public or private. In this case, I don't have any public addresses, so and then these are all my private addresses. Okay, so that's the demo on IP address space management. I'll go back to my presentation, and we'll delve into Windows Server 2012 R2. So there were a good number of investments that went into 2012. In 2012 R2, we have taken IPAM, DHCP, and DNS several notches higher in order to cater to modern day networks. So I would like to take a few minutes to talk a little bit about these networks. So the modern day networks have evolved a lot in the last 5 years or so. And what you see here is a typical topology of a network, the topology of a hoster or an enterprise network. It mainly consists of multiple data centers. These networks have different addressing, naming, and other service infrastructures and servers, and they don't necessarily reside in one single data center. They are spread across data centers. So you could have DHCP servers residing in one or more data centers, similarly DNS, NPS, etc. And then you have the multi or the hybrid kind of scenarios where you have organizations within an enterprise coming to the main enterprise and asking him for unique address spaces in the network. Or you could have, in the case of a hoster, enterprises coming to a hoster and saying that he wants to move some of his workloads and he wants a space in the data center of the hoster. In all those cases, you end up creating a virtual network for that enterprise alone, and the enterprise then moves all his workloads into that virtual network. This also gives rise to very interesting scenarios, like you could now have a DHCP server failover from a server in data center 1 to a server in data center 2. And not only that, this topology also gives rise to many different types of administrators. You have the network administrators that basically design the physical network, and then they go and assign IP address subnets, IP address ranges, and all that. They basically set up the base network, set up VLANs, etc. Once that is done, in order to cater to multiple tenants that are coming into the network, there are administrators that go and create virtual networks for all those customers, and those administrators are called the fabric administrators. And then you have the normal system administrators who go and administer all these different servers, both the physical servers and the virtual servers. So this is the layout, and this is the kind of networks that we generally have today with these kinds of administrative functions. Now IPAM and DHCP DNS in 2012 R2 cater to these kinds of networks. They offer a very scalable and a simple solution to go and administer your addressing and naming infrastructure in networks like this that consists of multiple data centers, and where data centers have multi-layered networks of this type. So going into the details of what we have done specifically in IPAM in R2, One of the main areas of investment has been the virtualized network automation. So all this time IPAM was monitoring only the physical address space and managing only the physical address space. Now it is capable of administering and monitoring both the physical and the virtual IP address spaces. And not only that, it also integrates with VMM. And since IPAM has a very good knowledge of the physical network, namely the subnets, the pools, the VLANs, etc., it can make all that information available to VMM. And with that information, VMM can go and build virtual networks or customer VM networks on top. So we'll be talking a lot more about that, and there will also be some demos in that area. The other important area where we have invested in is role-based access control, which I think will resonate with a lot of you because there has been a constant ask for this feature. Now, what role-based access control does is that it gives you granular control over the kind of administrative tasks that your administrators can perform. Now, this is very useful in multi-data center environments because that is where you have many different admins performing many different types of functions. So, RBAC allows you to specify what each admin can do, and you would not be able to do anything more than that. And we provide very fine level of granularity through RBAC. So, you can give control up to say a DHCP scope which is residing on a DHCP server, and that DHCP server could be present with a lot of other DHCP servers in a single building, which along with a lot of buildings could be residing in a data center. So, you can go to that level of granularity. And not only that, RBAC also allows you to provide admin delegation. So, as a super admin, you can delegate certain configuration tasks or management tasks to other admins with less privileges in your organization. So, we have strengthened the DHCP management that you can now do through IPAM, and all that is multi-server based. That is, whatever new additions we made with respect to administration of DHCP servers, you can go and do that across many DHCP servers. I'll again be talking more about that later. And while we are in infrastructure, let me take a few minutes to talk about what we have done in DHCP and DNS. There are a few investments that went in there too. For example, we looked at DHCP policies earlier. We now support FQDN based policies. So, you can use FQDNs to basically group the different devices and machines in your organization. And on the DNS front, we only had query statistics at the DNS server level for records. Now you can also do that at the zone level. IPAM got its entire share of PowerShell in Windows 2012 R2. It has 100% parity with the IPAM UI. Now, as you know, the IPAM UI can do a lot. So, imagine being able to do all that through PowerShell. So, that's excellent automation. And the IPAM PowerShell is also based on WMI v2, just like DHCP and DNS. Now, in 2012, IPAM was only interfacing with the Windows internal database. There was no way to add an external database and start using that. But in 2012 R2, we have added that capability. IPAM can now talk to an external database, which is namely the SQL server in this case. You can only interface with SQL. And SQL, brings in a ton of different features, like it can do, high availability, you can do backup and restore. So, all those functionalities can now be leveraged by IPAM also. So, this is a quick overview of what the design of, or the block diagram design of IPAM looks like. All that you see on the top is the design that we have put in place for the new features that have gone into R2. So, IPAM, in addition to WID, also interfaces with SQL, as you can see there. All the different administrative operations that you perform through IPAM have to go through the role-based access control layer. So, you are able to now enforce specific rules, and you can say that whenever an admin logs into IPAM, he can only perform certain tasks. IPAM interfaces with VMM. It not only interfaces with one VMM, it can interface with many VMMs. And for that, we have built a VMM plugin to basically enable IPAM and VMM to talk to each other. This plugin resides in the VMM server and it ships inbox. And given that IPAM is able to go and manage so many VMM servers at the same time, it is also able to detect IP address conflicts, overlaps, etc., and it can alarm the administrator on the UI. Not only that, it can also send those overlap and other information in the form of updates to VMM, and VMM can consume that and take action itself. For example, it would go and maybe log an event, or it can even show that on the VMM UI. The rest of what you see is pretty well known. We continue to talk to DHCP, DNS and other servers through many different protocols. We have these high level security groups still supported in R2. So, before role-based access control, you had less granularity in the control that you could give to administrators. You could just, divide all your tasks at a very high level and then assign them to different administrators. So all those capabilities are still there. Okay, now I'm going to delve into virtual networks a little bit, and to start with, I'm going to show you how data centers have multi-layered networks designed and the kind of address spaces they use. So like I had mentioned, you start with the physical network, which is the network that you have actually created in your data center, and that uses an address space, and that address space is typically referred to as the provider address space, and it is a network administrator who goes and puts this network together, creates the provider address space, etc. Now once that is done, all these different enterprises start coming in and they want to share or they want to move their workloads, they want to create virtual networks in your data center. So those are called the VM networks, or you can call them customer virtual networks. They use their own address space, and that address space is called the customer address space. Now what is interesting about these address spaces is that you either have the option to give them an address space yourself as an administrator, or the customer could come and say, hey, I don't want to use the address space that you're giving. I want to bring in my own address space. I use 192.168.0/24 in my network. I want to use a subnet in that address in my network that is residing in the cloud also. So that is the bring your own IP phenomenon that all of us are familiar with. Now there is a very high possibility that multiple customers could come to you and all of them would come with the same request. They might all want a 192.168 address space. So that results in address space overlaps, and for that you need to go and deploy network virtualization technologies like you have VLANs or you have NVGRE from Microsoft. And what this ensures is that there is no overlap, or these different virtual networks in the cloud are all segregated and they are able to function side by side and they are able to coexist, and you are able to isolate them well. Now when you bring VMM into the mix to go and create all these different virtual networks, then there are new concepts that come in. For example, you have the concept of a logical network in VMM. Now what a logical network is that it is basically a network that provides you a set of services. So it could be a storage service or a compute service, and all those logical networks are essentially carved out of your provider address space. They are carved out of your physical network. So they use the same address space. And what happens here is that you cannot actually route traffic between your provider or your physical network and the logical network for security reasons. In case you want for some reason for two machines in these two networks to communicate with each other, then you will have to use something like a network address translation in between. So this is a good picture of what virtualized networks to look like today. Now what is the role played by IPAM here? Now there are some challenges when an administrator goes about creating all these customer virtual networks and monitors them. There are a lot of challenges that he faces. For example, as a fabric admin, you would go and create a virtual network, and unfortunately you don't know what is the physical address space underneath on your physical network that virtual network is using. And once you have created this virtual network, you would want to go and monitor, what is the address utilization, where are my addresses going, do I need to add more? You are not able to do that kind of monitoring. You might end up actually just using spreadsheets or other makeshift tools to do all that. And the same thing happens with the physical network also, in the sense you might also, sitting on VMM, you don't get a view of what the physical network is, and so you don't know what is the utilization there, etc. Now if you bring IPAM into this mix, it goes and solves all these problems, because IPAM inherently solves all these problems. It has a very good view of the physical address space. It understands how to monitor networks. It understands how to monitor address utilization, etc. So when you bring IPAM is able to show you what your virtual network address space utilization is. It is also able to show you how virtual network address spaces map to physical network address spaces, etc. So now I'm going to show you a quick workflow of how IPAM helps you basically solve all these different problems that we just discussed. So we are talking about two networks, network admins again, or two administrators again. We have the network admin and the fabric admin, and you will see a series of tasks that each of these admins perform. So all the tasks that you see on the left, which are in cream color or peach color, are associated with the network admin, and then you will see some more tasks in light blue which are all associated with the fabric admin. So the network admin goes about creating the physical network, he assigns subnets, pools, VLANs, etc. And then once he has done that, since he is using VMM, since you are having VMM in your environment, you have to create this concept of a logical network which we saw earlier. So he then goes and creates logical networks, and all this is possible from the IPAM console itself. He does all this on the IPAM console. Now once he does that, all this information is synchronized and it is now available in VMM. So suddenly you start getting a view of your logical networks, what is the address space used by the logical network, etc. in VMM, and then you can go about creating virtual networks from there. Now there might be a need in some cases for you to actually go and make changes to the logical network or to the logical network address space from VMM itself, and if you do that, all that information gets synchronized back into IPAM. And like all other address spaces, the physical address space can continue to be monitored in IPAM. You can check the utilization, you can generate stats, trends, etc. Whenever IPAM detects IP address conflicts or overlaps, because it is talking to multiple VMM servers, it can flag that, it can send those updates to VMM, so you have all those nice things there. So as I mentioned, you can continue on VMM, you can go and create your virtual networks which are called VM networks in the VMM world, and all that information also gets synchronized and it is now available in IPAM. And once it is in IPAM, you can go and track them like any other address space. Another important thing to note here is that whatever you see in the left column and in the right column is what administrators typically do. Whatever you see on the left column is done by the network admin typically, and whatever you see in the right column is done by the fabric admin. Now whatever you see in between is basically handled by the plugin which I was talking about earlier. So it is completely transparent to these admins. They don't have to worry about all those different tasks. That is handled in the through the communication or through the synchronization that happens between IPAM and VMM.
Are there other plugins available?
No, there is only one plugin which manages all the communication between IPAM and VMM.
Sorry, is that an extensible plugin that was created for IPAM to connect to the System Center VMM solution? Is it extensible to other virtual solutions?
No, the extension that you have built now is only for VMM. Did I answer your question?
Yes.
Okay. So now I'll do a quick demonstration of what this IPAM and VMM integration looks like. So coming back to this view, we have this new section in the UI called virtualized IP address space, and then when you click on that, you see your IPv4 and your IPv6 address spaces. And when under IPv4, you see your provider address space and your customer address space. So we're going to start with the provider address space. And when I click on that, what you see here are different address spaces, the physical address spaces. So you can say that these are different data centers, right? And I'm going to be concentrating on this Dublin data center. And these are the different subnets that are present in the Dublin data center. Now, when I go and click on ranges, it shows me all the IP address ranges that are present in the data center. Now, if you look at these two fields which are of main interest, the managed by service and service instance. Now, managed by service essentially tells you who is managing these IP addresses or who is using these IP addresses. It could be IPAM because I created the space in IPAM, or it could be DHCP because I got the address space from DHCP. And then you have something called the service instance. Now, if I want to take an address space in IPAM and say, hey, here's my physical address space, now I want VMM to go and use it, I change the managed by service to VMM. As you can see, there are like two address spaces here which are already being consumed by VMM. And once you start consuming them through VMM, the service instance becomes important. So when you say I want to give this to VMM, you also have to specify which VMM server will use it. The reason for that is if you have a subnet, and if you have like two IP address ranges inside that subnet, you could give each range to a different VMM server. So that is where your service instance comes up. Now let's take this 50, 40, 30 address range and let's assign that to VMM. It's a very simple operation. I just right click, I say edit IP address range, which brings up this UI, and then I say managed by service is VMM. That automatically shows me the list of VMM servers. So I say I want this space to be, or this range to be used by vmm.contessor.com. I click apply, and you're all set. Now let me go and show you the VMM view, and you will actually see that address space there. So if I go to Fabric and I go to Network Service, what you see here, IPAM, is the plugin that I was talking about all this while. This is the plugin which makes everything happen. So I'm just going to go and refresh. Now all these refresh operations which take changes in IPAM and put them in VMM, take changes in VMM and put them in IPAM, happen automatically, but I'm going to show you the refresh every time because I want to just emphasize on what the design is end to end, how this actually happens. So once I click refresh and I click jobs, I can actually see the synchronization happening. So if you just wait for a few seconds, you'll see that complete, and then we can go and look at the address space available in VMM. So now it's complete. I go to logical networks, and then you will see this. So this is the address space that we had created there and we had assigned to VMM, and that is part of a logical network called public. So you see this network now appearing in VMM. Now that this network is there here, I can go and create virtual networks on top of that. So for that, I go to VMs and services. I say create VM network. I don't have any to start with. Let's say this is VEE Co. That is the name of my company, which is requesting for a private address space. I enter a short description, and then I say that I want to put this in public. So this is the logical network that got created in IPAM and which got synchronized to VMM as I showed you earlier. Actually, I forgot one step. I'm sorry. Before I go and do this, I go back to Fabric. So this is the logical network. What I wanted to show you was that when you bring an address space like that from IPAM to VMM, virtualization is not enabled on it. And in order to basically have multiple customer networks create, in order to be able to create different virtual networks for them, and in order to handle overlaps, I have to enable virtualization. So I'm doing that first. I forgot to do that earlier. I click OK, and then I go back to VMs and services, and then now I create a VM network. And I say VE Co. So I do public, and then I say next. So this gives me an option to choose what kind of addressing I want for my virtual network. I'm going to keep it at V4, and then it lets me allow subnets. I'm going to call this subnet 1, and I'm going to say 172.22.224.0 /16. Let me /24. So that's my subnet, and then I leave the rest of it at default, and that creates a virtual network. Now once the virtual network is created, you can go and create IP address pools in that. So let me create one pool and call it pool 1, and the VM network that I'm going to create this for is VECO, and since there is only one subnet, I have no other options here. I click next. So this is the range. I'm going to change this to 100 to 150. I'm going to reduce the range of IP addresses that can actually be consumed, and then I'm going to leave the rest of these settings at default. So when I do that, it automatically creates a pool in that virtual network, and all this time this jobs window was showing you information getting synchronized, but just to be on the safer side, I'm going to go and synchronize again. So I'm going to go back to Fabric, Network Services, select this, click refresh. Jobs will again show you everything synchronizing, and once that is done, you will be able to see your customer network in IPAM. So this is just going to take a few seconds. Yeah, so that's done. and I go back to IPAM, I go to the customer address space this time, and I click refresh, and when I expand this, you will see this VEECO. By default, it gets a name here. It says VEECO, whatever I created there, and then that is up, and then you go and append address space to it. So you will see your address space. This is what we had created: 172.22.224 and a /24 address. The address range is from 100 to 150. You can also go and look at your subnets, which is a single subnet, and as you can see, you can monitor the utilization here. Currently none of these addresses are in use, so it says 0. So once it comes into IPAM, you can go and do everything with that address space that IPAM allows you to do. You can go and define policies, you can define filters for it, you can do all sorts of things. So that was VMM and IPAM integration for you. Let's go back to the deck and let's start talking about the other topics that I have. So going to role-based access control, this is a very strong capability that we have added, and like I mentioned earlier, it gives you the ability to go and define granular control. It lets you go and define what each administrator in your organization can do, and you saw that it can go to a good level of granularity. Now let's see how you go about actually configuring it through IPAM. So it's a 4 or 5 step process. What you first do is you go and define a user role, and what I mean by user role is defining the list of administrative operations that an admin can perform. So for example, I could say that I want 3 admins to be able to perform DHCP scope policy kind of tasks. I want them to be able to go and create policies. In that case, I would create a user role called DHCP scope policy administrators, and then I would add all these tasks that are related to creating and editing policies for DHCP scopes. So that's user role creation. Now once you create user roles, you go and create something called access scope. An access scope defines the level of privilege that these administrators have on your network. They define the scope of the network on which these operations can be performed. So you are essentially going and specifying the portion of your network that these operations can be performed on. So let's, for example, imagine that you have a data center that has 3 sites, and each site has 3 buildings. Each building has, say, 3 DHCP servers. My scope could be a DHCP server, which will enable me to go and make those policy changes on all the scopes on the DHCP server, or my access scope could be the building, which will then allow me to go and perform those operations on all the DHCP servers in that building, or it could be site, or it could be the whole data center. So that is access scope. You go and define that. Once you have done that, you go and define what we call access policies, and this is where you go and create a list of administrators, or you go and create a list of administrator groups, and then associate them with the user role and the access scope. Now once you have done that, what you do is you go to your IPAM console, you pick the object that you want to enforce granular administrative control on. So going with the earlier example, I could go to maybe the DHCP servers in one of my buildings, right? I go to that DHCP servers, and then I go and associate that with an access scope. Now what I'm essentially doing or saying by doing that is, I'm saying that the list of administrators that I've specified in my policy can perform DHCP policy operations on all the scopes that are present on that particular DHCP server that I just tagged. Now once I do that, you have child objects under the DHCP server, which in this case would be the scopes. Now the access scope that you specified for the DHCP server is automatically inherited, and all the leaf nodes or your child object nodes get the same access scope. Of course, you also have the option to go and specify different access scopes for those DHCP scopes alone, and that gives rise to interesting scenarios. For example, I could be an admin and I have full control of all the scopes in all my 5 DHCP servers in one building, but I might say that I have these 2 administrators, I want to give them control only over one DHCP server. So though it automatically inherits the all privilege, I can say that these administrators have the privilege only for that DHCP server. So that kind of a delegation scenario is lit up by inheritance and configuring different set of access scopes for different DHCP servers. Okay, so this is the typical structure of your DHCP and DNS service in your data centers. So if you go to DHCP, the service basically could consist of multiple DHCP servers. You could have configured failover between one or more DHCP servers. Each DHCP server has many different configuration entities, like you could have scopes, policies, options, reservations, classes, etc. The colors that you see there are basically representing the utilization. So I'm talking about like these colors here in the leaf nodes. They represent the IP address utilizations of all those scopes. And IPAM allows you to go and monitor all this. It lets you go and make scope changes. You can add scopes, delete scopes, edit them. And in Windows Server 2012 R2, we have also provided the capability to go and define DHCP policies for scopes through IPAM. You can go and configure super scopes. You can configure MAC filters. You can do a lot of stuff through IPAM for DHCP. And then going up to the DHCP server level, you can go and configure failover relationships for two DHCP servers through IPAM. So all that is like management functionality. And then you can go and monitor. You can monitor utilization, like I mentioned earlier. You can monitor the status of your DHCP server. You can monitor and check whether there are filters defined or not, whether there is a failover relationship there. And then you can do the overall DHCP service monitoring. The same applies to DNS, which has a similar structure. The DNS service consists of multiple DNS servers. There are multiple zones on those servers. There are sometimes zones that are spanning multiple servers. Each zone has many DNS records. All this can again be monitored through IPAM. For example, you can look at the health of the DNS server. You can check whether there have been any zone replication errors. And then as far as the management goes, you can go and create DNS service records through the IPAM console. So that sums up, at a high level what the capabilities are with respect to IPAM managing DHCP and DNS servers. Next, I'm going to show you a pretty elaborate demo that will go over how you go and, perform some of these DHCP management tasks, and then we'll move on to role-based access control, and I'll show you how administrative or granular control is done, and then we'll look at how DHCP policies are configured through IPAM. So I'm going to be switching consoles again. Okay, back to this view. Now, this is where I go and view all my DHCP DNS servers. So you have DNS, DHCP, scopes, monitoring, etc. So if I click on DHCP and if I click on server properties, I know I'll see all the different servers running. If I click on failover relationships, I can actually go and look at all these failover relationships that have been created through IPAM. Now if I go to DHCP scopes, this is where I see all the different scopes that have been configured. It's a flat list, so I can go and group it, say by failover relationship name. So now you have the failover relationships and the scopes that are part of that. And if I go to the bottom, you'll see that there are two scopes that don't have a failover relationship as yet. So let's go and configure failover on one of them. Let's do it on this particular scope. So you just right click and you say configure failover. I'm going to use an existing relationship, and since the scope resides on DHCP2, as you can see, I'm going to choose the partner server to be DHCP1, and I'm going to put it in this failover relationship. The moment I go and choose the failover relationship, it automatically populates the properties of that failover relationship here, and then I click apply. So now it's going through the process of creating the failover relationship, and you will see the progress on the screen right here. There you go. And what you saw here are, high-level tasks that were performed to go and configure the failover relationship. So they are basically partial commandlets. There are like 2 or 3 different partial commandlets that get executed to pick a scope and create a failover relationship on it. And that is what you saw on the top there. And then I go and say OK. And when I say that, and then when I go and click refresh, you will see that this is now part of a failover relationship. It is here. So you will see 2 entries of that scope because it is now present on 2 servers. Next, what I'm going to do is I'm going to go and create role-based administration rules. And for that, we have added a new menu item here called access control. And when I go there, you will see roles, access scopes, and access policies that we discussed earlier. So let's start with role. And I'm going to do exactly what I had quoted as an example earlier. I'm going to go and create a role for DHCP scope policy administration. So I go to tasks, I say add user role, and I'm going to call this DHCP scope policy admins. And then I select DHCP scope operations, and here you will see that there are two operations related to policy that you can perform. I'm not going to allow him to delete, I'm only going to allow him to create, by the way. So I say configure and edit, and then I click OK. And that automatically creates this role. Now, as you can see, there are some built-in roles that are available in IPAM for your use. These are some of the popular operations that are performed by admins, so we provide inbox support for these different roles. So once I've created the role, I go and create the access scope. Now, access scope is where you go and define the portion of your network that these operations can be performed on. Now, when I create an access scope, you'll actually see the network hierarchy here. So I have the global level, and then I have two data centers, Singapore and Tokyo, and then both of them have different campuses or data centers under them. So let me go and create a new campus in Tokyo so that I also illustrate how you can create network hierarchies. So I just click new, I say campus 3, I say add, so that creates campus 3 under Tokyo. And when I click OK, you will see campus 3 here. So that is your access scope for the role that we defined earlier. Next, I go to access policy, and I'm going to create a policy, add access policy, and I'm going to first add a user. I can even go and use the AD functionalities that I have here. I have a user called test. Okay. Okay, so that's my test user. I click OK. So that automatically adds the user. And then I'm going to go and create the actual access settings. And this is where I go and define the user role and the access scope. So I say new. And then I'm going to choose DHCP scope policy admins here. And I'm going to choose campus 3. So this is the user role. This is the access scope. I click apply. And then I click OK. So that creates an access policy. Next, what I'm going to do is I'm going to go and tag this access scope on the DHCP scope that I created a failover relationship for. So I'm going to go back to DHCP scopes. I'm going to sort or group by failover relationship name. Go down to the specific failover relationship. I'm going to go there, and I'm going to say set access scope. So by default, it gives you global access. So I go and tag it with campus 3. Now, though there is failover relationship configured for this scope, you have to go and do that for the other DHCP server also, as you can see here, because it doesn't copy automatically. It shows that you could give different access privileges to the scope, to the same scope residing on different DHCP servers that are part of a failover relationship. So I go and do the same action again. I say set access scope, campus 3, and click OK. Okay. So next what I'm going to do is that I'm going to log out of this session, and I'm going to log in as test, and then you will see that he's able to go and perform policy operations on that. So before that, I'll just quickly check and make sure I don't have those policies already. Yeah, so I'm going to create some new policies, and I'm going to create an FQDN policy to show you the new policy capability that we have added. It is not here. So now I'm going to go log out and log in as test. So now I am logged in as test, and I can again group by failover relationship name. I'll see my failover relationships, and I'll see this particular scope here. Now I'm going to right click and I'm going to say configure policy. And I'm going to say, I'm going to call this FQDN policy. The policy condition is that I'm going to choose FQDN. So I'll first create the policy and then I'll tell you what exactly this policy means. So the condition that I've added here is that all the machines that don't have the contoso.com name, put them in one category. That's what I have done here. Okay. Next I go and create the actual rule or the actual settings. Now when you go and create FQDN based policies, you will only be able to define settings for DNS dynamic updates. You cannot define network settings for IP address assignment or DHCP policy options. We only support DNS dynamic updates. So I'm going to go to this particular setting and say yes. So I'm going to say that register it with a different name, and for that different name use this suffix. So I'm saying that all the different clients that come in which do not have contoso.com in their names, go and register them in DNS with the suffix guest.com. That's what I've done here. So once I do that, I say apply. Okay, let me try this again. Okay, there is something wrong, I'm sorry, but I can assure you that this works. I've tried it like multiple times back in my office, and for some reason, to prove Murphy's law, it's not working here. I'm sure that if I reset this VM, it will work. But what I was essentially planning to show you was that I would be able to go and create a policy. But if I try to go and do something else, like if I try to go and there's something seriously wrong here, looks like. Okay, fine. So what I wanted to show you was that if I went into that scope and if I tried to do any other operation, like change the IP address range on that scope, it would not allow me to perform that operation. It would just error out. So what I'm going to do is I'll just reset this VM. I'm pretty sure it will work then. And while it is coming back, I'll go back to my presentation and talk about other things. And then we can come back to this demo. Okay. Now, I want to talk a little bit about the integration capabilities that IPAM provides with external systems. Now, IPAM, as I mentioned earlier, has complete partial support, and it is a very flexible partial support that we have added. So, through partial, you can go and integrate with a multitude of external systems. For example, you can go and integrate with SCCM, you can go integrate with ADDS, you can go integrate with the map toolkit. And the integration is both ways. That is, you can go take information from one of these systems, retrieve them and put them in the IPAM database and view it in a UI. Similarly, you can go take information from the IPAM database, export them and import them into your external system. So I'm going to use the example of network discovery to take this discussion further. So network discovery here means I want to go and check what are the IP addresses in my network in a given subnet that are currently in use. So what I do for that is I can go to SCCM, write a partial script that uses an SCCM commandlet to go and retrieve information from SCCM. And once I have that, I can massage it and convert it to a format that IPAM supports. Now, IPAM provides a very flexible and a very robust object model. It has this concept of custom fields. So, if there are some properties in the SCCM object that is not known to IPAM, it can be mapped to custom fields and the data gets stored as metadata. So, when you do that, you are essentially massaging your data, you feed it into IPAM, you call an IPAM commandlet essentially to go and put it in the IPAM database, and once it is available in the IPAM database, you can go and view it in the UI. And you can actually even perform changes in the UI. You can even change all those custom fields, export them and put it back in SCCM or map or whatever the system is that you're integrating with. Now, in the reverse case, what happens is that since IPAM has a good knowledge of the network, SCCM can leverage that knowledge and build policies. So, SCCM could build policies like don't go and put patches on subnets that don't have any machines assigned IP addresses, or go and put specific patches for clients that have been issued IP addresses from a range that was meant for remote access clients and things like that. So, you can build many different flexible policies through this integration. Another case is the integration that we provide with Active Directory services. Now, ADDS has this concept of sites, and each site has a set of subnets associated with it. So, you might want to actually import all these subnets into IPAM and monitor them there. So, that's possible. Again, you write a partial script that exports the ADDS site information and subnet information and feeds it into the IPAM database through IPAM commandlets, and once it is there, you can go and view it in the UI. You can even go and make changes to the site. You can add more subnets and all that, and then you can export and put that information back into ADDS. So, that's the kind of integration you have. So, what I'm going to do next is I'm going to show you a script which basically goes and pings the network. It pings a particular subnet in the network, discovers all the IP addresses that are in use there, and it is going to populate the IPAM database. So, let's go back to our demo window. I think my IPAM server is up, but I'm going to first show this demo and then I'll move to policies. So, that brings up my server manager, and you will very soon see IPAM here. So, I am going to go to my script location. So, that is my IPAM console. I go to IP address inventory, and this is where you will see all the IP address getting populated once they go and get discovered. So, currently it is empty, and I have a partial script here. It is called ping sweep, and what it does is it goes and takes a subnet configured in IPAM, and then it goes and checks all the IP addresses that are present in that subnet. And then when it is able to find a response, it adds that IP address to the IPAM database, and then you will be able to go and see it in the IPAM UI. So, I am going to run this script, and while it is running, I am going to go and refresh IP address inventory, and you will see the addresses appearing there one after the other as they get discovered. Luckily, this demo is working. So, I have like 5 or 6 different addresses that are in use, and you will see all of them here. So, that is the IP addresses, and you can see that they are all from this range, and these are the specific ones that ping could detect as used in the network, and then you have all the different properties associated with that IP address, the DNS information, DHCP reservation information, all that is available. So, next I am going to show you how this integrates with DNS. So, I have a DNS server here which has many different resource records in one of its zones, and I have a script here which is going to retrieve all this information It's going to retrieve all these records and it's going to push them into the IPAM database again, and you will be able to view those records in IPAM. So this is the script that I'm going to run. And there are like at least maybe 100 or 150 records. So slowly you will see them appearing in IPAM, and again they'll all be visible here under IP address inventory. Yeah, so it's already populated it with, you see all these 172 addresses, they are all from the DNS server. So as I keep clicking refresh, you will see more and more of these addresses appearing. There you go. So after a few seconds, once the script is done, I'm going to go and show you the other demo again, and I'm hoping, keeping my fingers crossed and hoping that it works this time, so that I can show you how all the RBAC and the policy configuration works. So while that script is running, let's do a recap. So I had my scopes here. I sorted by failover relationship name, and we put this particular scope as part of this particular failover relationship, and we added these role-based access control tags to them, and that's where we stand. And once the script is done, okay, actually we don't have to wait for that, we can okay. Okay, so I think all of them have got populated now. So let me switch and log in into the IPAM as test user, and then see if I'm able to create the policies this time. So I say switch user. Say test. So I am now logged in as test. I go to the IPAM server. I go to DHCP scopes. And I see my scopes there. So let me go and try creating the policies now. Actually, just a second, I'll make sure that those policies are not there here. Yeah, they are not there, so it should work. Go to this scope. I say configure policy. I call this FQDN policy. I say new condition, I say FQDN not equals onto the .com, use wildcard and prepend add condition, and then say register with guest.com in the DNS. So I'm just hoping it works this time. Okay, I think it's just a bad day, and I'm not going to attempt this anymore. But you can be assured that it works. I don't know, I tried this like 15-20 times before I came here, and it worked. For some reason, it's not working now. And it says it doesn't have the privilege when I actually do have. So I'll have to go and check this. Anyway, so that's all I had. Coming back to the presentation. So the key takeaway, as you saw, was with the 2012 R2 IPAM, you have a cost-effective, scalable, and a customizable solution for unified management of your different address spaces and your DHCP and DNS servers not only can it be used in enterprise, but also in hosted environments. So there are many different resources that are available out there which can give you more information about 2012 R2 and the features. And then there are some related sessions that we have. I think all these sessions are already over, but then you can go and watch their videos. They're all pretty good. I attended some of them. And then I have an instructor-led lab tomorrow. It's at 10:15 in the morning. And you know where all the instructor-led labs are, right? It's at the other end of this big hall. So if you want to try out some of the Windows 2012 R2 features, please do come over to the lab. And then we have many different resources out there, Channel 9, TechNet, MSDN. And then please go and complete an evaluation of this session. Please give me your feedback so that I can improve and make a better presentation next time. And for all those who give feedback, you enter a lucky draw and you have all these different gifts there. That's all I had. Thanks a lot, folks, for attending the session. I hope it was useful. I can now take questions, or you can also come and talk to me later.